Hello again. In part first of this tutorial, we simulated the reactor where methane reacts with steam to produce the wet syngas, carbon monoxide, and hydrogen. This is a methane reforming process. So this syngas contains some unreacted methane and steam, and of course the products carbon monoxide and hydrogen. This steam is passed to pressure drum where the temperature is reduced to 105 degrees C. So the water is condensed and it is recycled to the reactor. And the top stream, which contains the gases, hydrogen, carbon monoxide, the CH4, methane, and some water vapors. This stream is passed through a hydrogen-selective membrane. So at the permeate, we get mostly hydrogen. This is like 90% pure hydrogen, and the rest of gases are obtained as retentate. So in the part first, we simulated this system up to the flash drum. In today's lecture, in today's tutorial, we are going to simulate this membrane. Okay, this hydrogen selective membrane. So unfortunately, there is no unit operation for membrane, so we need to write our own equation in calculator block, and those equation will be simulated, and we will get our required results then. So these are the equation. Suppose we have developed this model. So we have four equations. This is the recovery of CH4. The first equation, this is the recovery of CH4, 1 minus exponential minus PCH4. PCH4 is the partial fraction of CH4 and divided by this number. Similarly, for H2 recovery in the permeate, this is the equation. For the hydrogen recovery in the permeate, this is the equation, and similarly we have equation for the carbon monoxide recovery. So here this R is actually recovery and P is the partial pressure. So now I am going to script this equation inside the ASPEN custom model, the calculator block, and then we will see that these equations will be solved, and we shall get our desired results. Okay, here we shall install go to the separator, and from here, from this SIP block, select this SIP and install it here. Okay, escape, call this membrane, and this is going here. Let me just call this SYN D gas, and two streams are leaving. Okay, I will call this as a permeate stream, and another stream we'll call this as a retentate stream. Okay, double click on this membrane unit, and just enter some dummy values here. Let me just write 0, 0, 0, and 1. Okay, these are not the actual values. These will be actually calculated by the calculator block when we enter our equations. However, the software, this is the requirement that you need to specify this. It means permeate, that in the permeate 100% H2 is recovered. It means there is no CH4, H2, and CO. Okay, these are just these are some made up number, and I will write those equation in the calculator block, and then these number will be changed. These will be actually overwritten. Okay, so these will be overwritten in the results. Now go to the flow sheeting option, click on calculator block, and a new calculator. So here we need to define our variables. So this is RCH4, recovery of CH4. So this is a block variable. And which block? Membrane block. Which variable? This is flow fraction. ID1 mixed stream. ID2 this is in the permeate. And recovery in the permeate. Which component? CH4. Okay. So we also need to define this for H2O, carbon mono, and hydrogen. So just copy this and click on paste. So here you can see a copy of this RCH41. Just rename this with RH2. Okay, and change it from CH4 to H2 here, right? Similarly, make another copy. Just click on paste, and this is RCO. Okay, change this to CO. Similarly, another copy, just click on paste. So this is RCH4, and let me call this RH2, right? This is RH2O, RH2, and change this to H2O. So these we have defined these variables. We can view from here. So this is recovery of CH4 in permeate, recovery of H2 in permeate, recovery of CO in permeate, and recovery of H2 in permeate. Okay, now I define the mole friction. So just click on new, and let me call this XCH4. So this is mole friction of stream. Which stream we call that? Okay, why I'm defining the mole friction? This is actually the you can see here that partial pressure is used in this equation. However, there is no such parameter in the ASPEN in the results. So we know that partial pressure is given by mole friction multiplied by total pressure. So I will define the mole friction of component in the feed stream, and in the total pressure of that component in the total pressure of that stream. And you know that XA mole friction multiplied by total pressure is equal to the partial pressure. So that's why I am defining this mole friction instead of the partial pressure. So this is the component is CH4, right? Then copy and paste X H2O, change this to H2O. Another paste X CO, and this is CO, and another paste X H2, and change this to H2. You can see view from here. So we have defined the mole fraction of H2, mole fraction of carbon mono, mole fraction of carbon H2O, and mole fraction of CH4. Okay, also we need to define the pressure. So just click on new. I call this P. So this is a stream variable. Which stream? This MD. Now this is pressure, and the unit is in bar. Okay, now we need to write the equations here. So click on calculate, and 6 phases, 1 2 3 4 5 6 here. So this is 1 2 3 4 5 6. Now write your equation. RCH4 is equal to 1 minus exponential minus x steric CH4. Sorry, this is x CH4 steric P divided by 1115. In another equation, just copy and paste this. So Control C, Control V. So this is RH2O. H2O, this is equal to 1 minus exponential minus x H2O divided by 160. Another control V, and this is R H2 1 minus exponential minus x H2 steric P divided by 8.8. Another equation is for the CO. So this is equal to divided by 305. Okay, now click on sequence, and these are the import variable. These values will be used. This XH2, XCO, XH2, XH4, P to calculate these recoveries, RCH4, RH2, RH2O, RCO. Okay, now just click on run the simulation. So it says that results are available, and just now go to the membrane and click on the stream results. And this is the mole flows, and this is the mole friction. So you can see that in the permeate we have 99% hydrogen is recovered in the permeate, and you can also check the mass flow, the mass friction, and so on. Okay, sometimes you may not be able to converge, so let me just run it again, and sometimes you may get this problem. Your simulation may not be converged. So in that case, just go to the flow sheet and disconnect this recycle stream. Okay, disconnect it. Click on the calculator block 1, C1 input, and click on this calculate and remove this minus FR. Run the simulation. So you can see that it is converged now. Results are available. So this is minus FR. Again, write that FR and go back to the flow sheet and recycle this to the reactor. And now run the simulation again. So now you can see that the simulation is converged, and you can see that results are available. So that's all. Please like this video and share with your friends and colleagues. Thank you very much.